Got a big 2 weeks here to wrap up the semester. It's really important that you kind of dig down and stay on top of things because this is probably the last big lesson of the semester. We're going to throw quite a few things at you, a little bit of vocabulary, some things that you've probably seen back in middle school. So we're going to talk about scatter plots. And your goal is to use scatter plots to describe a relationship between two data sets. And you should be able to make one and draw a trend line and write its equation. So a lot of things, but some of the stuff we've already done, some of it you've seen in middle school. We're going to kind of throw them all together. So an association is a method of describing a relationship between two sets. And then we have some special cases of associations where it is linear in nature. So we have three types: positive, negative, and no correlation. These are going to, later in the lesson here, if it's positive, it's going to relate to having a positive slope. And if it's negative, it relates to a negative slope. This one here, you can't find a slope. So we know that if we have a positive correlation, we have a positive slope, which means as our x increases, our x goes this way, our y increases. And here, it's negative. As our x increases, what's happening to our y values? Our y values are decreasing. And then what happens here? No correlation. X and y are not related. So as I set up here, I talked about some slopes. When we do this, it's called a trend line, or as you see over here, a regression line. It is a line that models the data by showing the general direction of the data. A trend line fits the data as close, as possible. So if I were to draw a line this way, that doesn't fit the general direction as close as possible. Same thing if I went this way. But this one here that goes kind of right through the middle, through most of the data, and follows that trend, that would be a good regression line or trend line, line of best fit. They're all kind of used interchangeably, so a lot of vocab there that all means the same thing. So moving on to some examples. What is the relationship between the hours after sunrise x and the temperature y? So after the sun rises, I think I might have just said sunset up there, but this one's the sunrise, sunset's the next one. We know that especially in spring and summer, as we go further throughout the day, the temperature tends to rise, and then it will kind of level off maybe dinner time-ish. But in general, throughout the course of the day, as the temperature goes up, so does the number of hours the sun spent up. So what is the relationship? As hours increase, temperature increases. And we know this is a positive correlation. If we go back up here. Go further down here. What's the relationship between hours after sunset and the temperature? So we know that as the hours increase, the temperature decreases. And this is a negative correlation. So if you wanted to put the word correlation there, you can, or you can just write negative. We don't hear this last one here talks about the relationship between hours after sunset and the amount of rain. We don't have a relation there, or correlation, however you want to write it. Some of these words, again, get used interchangeably. You'll see no correlation, no relation, a lot of different things here. But so no relation, no correlation. Just know there's not a relationship there. So I don't like how A and B are written here. So I'm going to kind of just change up these directions. It says, how can the relationship X and Y be modeled? So I think what they're asking here, how can it be modeled? Well, it could be modeled like this. If I wanted to take a trend line, I could put one here and then draw a line through and cover as much of the data as I can and make sure I get that general direction. And we'll call that good. So it can be modeled like that. And then the follow-up question. So this is, it's positive. We know that it's positive, because we already did this one in the previous example, but now we're going to go a little further. So it says now, if it can be modeled with a linear equation, describe it. So now that really what they should have just said, write a linear equation. That would have been a better way to write this question. And you actually see in the homework, it does a better job of saying that. Write a linear equation. That's what we're going to do here. You have to be careful because these are going up by 2. So 60, 62, 64. These ones are going up by 1s. So the further you get into algebra, the less you're going to have things just be 1 on the scale. It might go up by 2s, 5s, 10s, whatever. The best way to do this is to use, you could use point slope. This one here, my trend line does go through my y-axis, so I could do that as well. But for me, let's see here. You could pick a point like right here. It looks like it goes right through, and we'll say right here. So I picked 2 points that are on my line, and they don't have to actually be the dots. And now I gotta go all the way up to this point here. So I went up 2, 4, 6, 8. So my slope goes up 8. So my slope. And then I go over 1, because these are going by 1s instead of 2s. 2, 3, 4, 5, 6. I went over 6. So I have a slope of 4/3. And now I could pick any point on here. The best way to do this is point slope form. That's how it's going to be on your final exam and your exam. We'll probably tell you to do point slope form too. Remember, point slope form is y minus y1 equals my slope times x minus x1. So if I picked an easy point here, we could just do 1, 60. That seems to be a good point. So y minus my y1 is 60 equals my slope, which we said was 4/3 of x minus x1, we said was 1. So that's an equation. And you could take this and do your distributive property and add 60. And what you'd see is that when you did that, it would give you a y-intercept of 58 and 2/3, I believe. Which, you know what? Are we 58 and 2/3 here? We're pretty close. But just leave it in point slope form is the best way to go. So we're back to this other one. How can it be modeled? So we said that this is negative. We already did that. We'll put a nice trend line here. This is where having a straight edge would help you. Again, we don't want it here because that doesn't match it. Try to go through, pick your spot, and go there. Remember, the other way to do this, depending, you would have to look at it. If it was a multiple choice test, hint, hint, you would want to see how your answers are written. If the answers are written in point slope form, you would want to do this. If it was written in slope intercept form, we could do it like this. So again, this goes up by 2's. Look right here. I have a y-intercept of 71, we'll call it. And then what's my rise over run? Let's pick a good point there. It looks like it's 268, and then go find another one. I don't know. We'll come down here, I guess. I try to pick them as far apart as I can. It just gives me kind of a better snapshot of the data. And how far did I go? Well, I go down 2, 4, 6, 8, 10. And then I went from 2 to 10. So I went down 10. And then I went over, that would be 8. So remember, when we go down 10, that's negative. So I have negative 5/4. So if I wrote this in slope intercept form, so we got y equals mx plus b. This is my b right here because that's my y-intercept. So I have y equals negative 5/4 x plus 71. And last thing we're going to do here, so hold on just for a few more minutes here. Talking about downloading various files for different internet speeds. This is tricky because these are really small numbers. So here I could do 35, 40, 45, 50, 55, 60. That'll work. And we would need a broken line here, like we had up here. See how we got a broken line? That lets you skip points. So we put a broken line there, and then we would have 35, 45, 55. Over here, I only have to go between 3 and 7. So I could do 3 here. So if I did another broken line, I could do 3 here. Let's see if this works. 4, 5, I'm skipping 6 and 7. So now I can graph my points. And I'm going to pause the video here, and you can pause as well and graph. So I'm just going to do the first one. So I go to 35, and I go to 6.65. Make a mark. And then I'm going to do one more here, 40, 5.82. Make a mark. I'm going to pause the video now. Okay, in the essence of time, you can see I just kind of finished this up. You guys know how to graph. You're in high school. It says write an equation of the trend line. This is where you would need to do the following. Now that we've done this, and it's nice this is a different color, I could start here and try to go through as much of the data as possible. And we'll call that good. It says write an equation on the trend line. So in this case, I'm trying to find some points that work. I could use this one here. So I'm going to change this color to red. So I could use that point there. That is 40,6. And then I could use this point here, which is 60, 3.5. You gotta be careful, these go down by 0.5. So what happens to my slope? I went down So I went from 6 down to 3.5. So I went down 2.5. And then I went over 5, 10, 15, 20. So your scales are important. So that's really kind of tricky. That's negative 2.5 over 20 is my slope. You could put that in a calculator if you wanted. At that point, you don't want a decimal on top of a fraction. So we do 2.5 divided by 20. And you're actually, it's going to reduce to 0.125, which is actually 1/8. So whether you wrote this as negative 0.125 or a negative 1/8, if you caught that, whatever works for you. So that's my slope. And then pick a point. Well, we could just use 40 over 6 and call that our x1, y1. So write an equation. So you have y minus 6 equals my slope, negative 1/8 times x minus 40. And just stop right there. So then they ask you a follow-up question. It says, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? So how long would it take it to download? And what you'll see is that this actually goes off the chart. But remember, we had these broken lines here. So it doesn't go off the chart. You don't have a negative number. It's just we really made the graph specific. So if you take your calculator, you would have y minus 6 equals negative 1/8. And 75 seconds is our x. So we do 75 minus 40. So that becomes 35 in parentheses. And this is where you would have to take your calculator. So if you already have your calculator out from the last problem, it says, so I'll make that negative 1/8 times 35. And then I have to add 6 to it. So if I add 6, I would get, just using this without showing all the work, y equals 1.625. I'm just going to pause it here. Wait, here's the math behind that. If you're interested, I did negative 1/8 of 35. It says, what is the x-intercept of the trend line? Is it possible in a real-world situation? So what they want to know is what is the x-intercept? The x-intercept is when y equals 0. So when y equals 0, what do we get? And what does that mean? Well, we'll get to what it means here in a second, but let's finish this up here. So we have 0 minus 6 equals negative 1/8 x minus 40. We're going all the way back to this equation up here. So this here equals negative 6. You have to do some math. You have negative 1/8 x. And 1/8 of 40, so you do 0.125 of 40 It actually equals 5, and these two negatives cancel. So it becomes positive. Now we have to go all the way back to the beginning of the year algebra. What do we do here? Well, we subtract 5. That becomes negative 11. How do we get rid of a fraction? You multiply by the opposite. And you get an answer of, so those cancel there. You get an answer of x equals 88. Is that possible? So we come up here, and what does this mean? We get 88 and 0. What does that mean? It means if you had an internet speed of 88 kilobytes, you would be able to download that file in 0 seconds. Is that possible? No, you can't. So is this a real world? No. And explain. You can't download in 0 seconds. So I'm sorry the video was so long today, but we will make it easy on you. We're just going to do one through 5 for starters. Page 23, 1 through 5. Oops, sorry. Page 23, 1 through 5. So that'll take you 20 minutes, and that'll be 45 minutes of math for the day. We'll finish up the rest on Wednesday and then get ready for the test.